So about 3 years ago, I was working on my previous startup company. We were doing automated matchmaking between students and internships. And I got this email from a friend of mine that I'd worked with previously on the race car that was mentioned earlier. And he asked me whether or not we were applying AI and machine learning as part of our algorithms. At that point, 3 years ago, I said, I don't know what this AI thing is, so I'm going to say no. Fast forward 3 years, and I'm the CEO and co-founder of an AI company. We were recently announced by Fast Company to be one of the 10 most innovative companies in the world in artificial intelligence. And I've been asked by Singularity University to come back and be, I was there a couple of years ago, and I've been asked to come back and be faculty in artificial intelligence. And I'm not telling you that because I'm especially cool. I'm telling you that because this artificial intelligence thing has come up really fast. And I felt for a while that I didn't really have a voice in this. Like, I don't code. I don't have a PhD in computer science or data science. I don't really feel like my voice belongs. I don't really feel like I have a message or anything to say. But what I've come to understand is that each of us, each of our voices, is going to be super important in the future of technology in general, but especially in artificial intelligence, because first of all, it's going to seep into every single part of our lives and our professions. And secondly, there's going to be some big challenges in it. So it's important that we all understand more or less what it is about, and more important, how our work will be affected and how we can be part of that revolution. So if nothing else today, what I'm hoping is to get you a little bit of a feeling for what AI is, for those of you who feel like that's just a big fluffy cloud of words that I have no idea how to understand, and a little bit of empowerment. We each have a say in the future and how we want the future to be, and it's important that we participate. But we're going to start a little bit with the basics. Are there anyone here who's not familiar with Moore's Law? Okay. Well, a couple. Okay. So very, very briefly, it is about both storage and computational power. And if there's any, solid academics in the field in the room, my apologies for simplifying. But about every 18 to 24 months, we double the price performance of our computers. And this doubling is exponential in its core, which means if you take 30 linear steps, which is how our brains are wired to think, right? You take 30 linear steps and you get to about 30 meters. Great. If you take 30 exponential steps, as in 30 doublings, as in the pace with which technology is developing, and it's not just Moore's Law, that's just one of the laws of development. If you take 30 exponential steps, you're going to be about 25, 26 times around the Earth. So technology develops really, really, really fast. And because it develops really, really fast, and because we think linearly, we're going to end up thinking like this. And it's not the Thomas Watson, smart guy, right? But it's really hard to see the future. And that's where we're at with artificial intelligence and a variety of different other technologies as well. AI is just one of them, and it's converging with things like 3D manufacturing and the more we understand about genomics, etc. So, to quote Salim Ismail, we're having about a dozen Gutenberg moments all at the same time. And that's why we keep hearing words like disruption and craziness and exponential all the time, because we're seeing all of these streams of technology developing and doubling every, say, 24 months. But let's dig into, so that's kind of just the backdrop. Things are moving really fast. And it's easy to get disillusioned with both what's happening now and what will happen in the future, because our brains just aren't wired to see it coming. But let's get very, very concrete with artificial intelligence. The basics, the way I think about it, is that the difference between AI, which at the end of the day is just software, the difference between AI-type software and regular-type software, if we can call it like that, for simplifying a little bit, is that regular software works more like a calculator. We can calculate really, really large numbers, store large amounts of data, but at the end of the day, if you go A plus B, you get C every single time, and it does that every time. However, an AI system works more like a human brain and is often modeled more after the human brain, even though we really don't know that much about how the human brain really works, but the way we think it works. And that means that it is a system that learns over time. You put A plus B equals, and you get C one day, and then, as you train it over time, you may get C or a variation of C or something completely different. So it's a system that learns over time. And when we say, when we talk about the data that goes into an AI system, of course, we're talking about images, we're talking about text, we're talking about numbers, anything where you can use vast amounts of these kinds of data to see patterns. And the question is, of course, I mentioned AI systems are software that learns over time. Now, how does an AI learn? Well, it's pretty straightforward, very much the same way as a human. As I said, it's modeled and shaped similar to a human brain. So you've got the unsupervised learning, which is pretty much the same as giving a kid a book and having them read that book. And they learn on their own. They might draw some good conclusions, some bad conclusions. It's unsupervised. You give them a book and let them learn. And the way to do this would be to give an AI system, 100,000 or 10 million different images and ask it to find patterns. And it will, and sometimes the pattern will make sense to us, sometimes it won't. Then you have supervised learning, which is where you need a human to be part of the learning of the machine. So you have a human that comes in and tells the machine, yes, that is right, no, that is not right. So you have a human in the loop in a training data set or an annotated data set, and the machine learns from that. And then you have a third option. The challenge with supervised learning is, of course, you need a lot of humans. And we're already seeing quite a few humans employed as AI trainers, that being their job title. And that is, of course, limits to how scalable it can be. It means that companies with a lot of money can train their AI systems, while smaller companies, potentially academic institutions, will have a harder time actually training these AI systems because you need a lot of humans. Then there's a third way of teaching an AI system, which is up and coming more and more. It's one of the reasons I'm sure most of you will have heard about Google DeepMind's AlphaGo that managed to beat the world's leading Go player, which is an absolutely astonishing accomplishment, and was done more than 8 years before the researchers building it thought it could actually be done. So they were amazed themselves by the system. And that was due to, in part, what's called reinforcement learning, which is kind of like group work for machines. So you give two algorithms a similar kind of challenge and have the algorithms compete against each other in solving it. Simplifying it, but that's the essence of how it works. So that is how these AI systems learn. But I want to go a little bit back as well, because the thing about AI, it's suddenly something that everyone talks about, right? It's everywhere, at least in the news I read. It's everywhere, mentioned in every single technology article I read. But it's not really a new thing. The term was coined in 1956. Alan Turing being one of the pioneers before it was actually the term artificial intelligence, proposing the Turing test already back then, which is at the point when a machine can pass as a human, and we're not there yet, and we're actually quite a few years from it as well. Although there have been the first few projects now claiming that their machine has passed the Turing test, they haven't really done so. But we're getting there within a few years. So it's been a scientific field for a number of years, but there's been a couple of limiting factors, one of them being access to computational power. In order to do research on AI, you have to have access to a supercomputer, which you had if you were employed at a university, but you didn't anywhere else. The same goes for data sets. But, and of course, mentioning iRobot and a lot of science fiction as well, which, in which AI has existed even longer than in research. The things that have happened over the last few years is that, first of all, with cloud computing and Amazon and Google and all of the big companies and service providers giving us access to pretty much unlimited data and processing power, meaning that You don't have to work at a university with a massive supercomputer. 2 kids in a garage can have access to enough computational power to actually build AI or machine learning applications. The second, of course, is the introduction of the internet, where suddenly all data, more and more data, is becoming readily available to us. And so since from about 2012, although AI has existed for a long time, had its ups and downs and AI winters, from 2012, we suddenly have this immense and massive power and an ability to actually apply the things and the algorithms and the approaches that have been theoreticized about and researched on for decades. And that is why we're hearing all about artificial intelligence these days. But one thing that's also really important, because when you look at media, who has a tendency to, exaggerate a little bit for clickbait, there's 3 ways or 3 kinds of artificial intelligence. And the one that is usually talked about when we talk about Skynet and, all of these crazy futuristic dystopian scenarios, that is artificial superintelligence. And we're still 20, 30, 40, no one really knows. We're still a far number of years out from having artificial superintelligence, as in when one machine is smarter than all humans on Earth put together. We don't really know what's going to happen at that point, and that's the scary part, and that's why we talk about it in a little bit of a dystopian way, or utopian. I'm on that side. But we're far out. And remember that by the time we get there, we will know a lot more than we do today. So yes, we need to discuss it, but there's other ethical issues and consequences that we need to discuss sooner than that. Then we have the artificial general intelligence, where these systems or machines are as smart as humans. Now, we're still years until that is going to happen, and that's kind of when an AI is going to pass the Turing test. It's really hard to estimate when, but 10 years, 15 years? Only time will tell, of course. And where we're at right now is artificial narrow intelligence, or as some people call it, enhanced augmented intelligence. As in systems that can do one thing and one thing only, and that's what they do. An example of this is if any one of you has picked up the phone and called your health insurance provider or your bank, and you have this voice that says, "Hello, please state what you want, and I'll find the right person to talk to." And you say something, and they may or may not understand you. But if you ask them what they had for dinner last night, you're not going to get an answer, right? They know one thing and one thing only. Another example, which I've actually fell for this. I emailed someone, and they emailed me back and said, "Yeah, sure, my secretary can help us find a meeting." And the secretary, Greta, emailed me back and said, "Here's a couple of examples or a couple of suggestions for a meeting time." And I emailed back and forth a few times until I realized that this is not actually a human. This is a machine. So these, AI personal assistants for specific meeting bookings is coming right now. Actually, one of my coworkers was CC'd by mistake on an email with a couple of people trying to get dinner, and their AI assistant kept trying to get her to say yes to the invite as well. And she's like, no, I'm not actually invited. But it was really hard to explain that to the AI, because that goes outside of her or its or his narrow intelligence field, right? It's designed to do one thing and one thing only. It's not trained for anything else. And as I said, artificial intelligence has exploded, both in capabilities, yes, but perhaps even more so in media, in our discussions of it. It is essential and it's vital, but it's also a little bit overhyped. And this is one of my favorite examples of that, Rocket AI. A friend of mine, she was at the NIPS conference in Barcelona, which is full of experts in the field. So this is a proper academic conference in machine learning and language understanding. And they put up these flyers for the launch party of Rocket AI. Super exciting. 300 people showed up. There was free beer. The police was called. It got a little crazy. Good launch party. The day after, she got 5 phone calls from prominent venture capitalists asking to learn more about this algorithm. And for those who can read it, the algorithm is called temporarily recurrent optimal learning. Great, trademarked, all of that. If I'm going to spell this one out for you, it was not real, right? In a kind of drunken stupor the night before, they'd said, wouldn't it be fun if we did this random company and had this random launch party and tricked everyone? And they managed to do so. And these are a room full of experts. So it's really easy to get carried away when people say, we've built this exciting new thing that's going to change everything, right? There is that hype. And it's important to kind of keep our minds cool in this. On the other hand, it's really easy to be disillusioned with AI. Siri is not that smart. And what it leads to, though, this kind of hype and this, well, when we see the actual, use cases of what is applied, it's really easy because, as I said, we think linearly. Nope, the laser pointer is not working. We think linearly. So the blue line is what we expect. We expect little by little by little for these tools to get better and better. So when we've used Siri for a year and we don't really see any big changes, we're kind of disillusioned. And this AI thing is, it's not all that it's made out to be. However, as we talked about, the exponential growth of it means that the early growth is not quite as good as we had hoped, while at some point, it's going to take off, and it's going to absolutely blow our minds. Which means that we kind of need to get involved already now so that we're prepared, with the right expectations of what's possible now, so that we're prepared for that takeoff. And I kind of think about AI in the same way I think about kids learning, right? Even if a kid doesn't quite get the alphabet right at the age of 3, 4, we still have great hopes for their future. And we're patient, and we let them learn, and we let them make mistakes, and over time, they're going to grow up to be spectacular adults that can do really, really, beautiful, wonderful things. So we need the right expectations. And then, of course, again, AI is being talked about a lot. So the question is, what areas of our lives will change as a result of AI, of our businesses, our jobs, our personal lives, all of that? And matter of fact is, all of it. Much the same, the internet has kind of snuck into every single part of our lives. AI applications will as well. Actually, it kind of already is. If any of you has an iPhone, I guess a few does, their image recognition software in the phone right now can classify all of your pictures based on who's in them. Now that's an AI algorithm, machine learning algorithm. AI is really just a big umbrella term for all of these different terms. So we're already surrounded by AI applications. It's just that when we actually know how they work and they seem fairly straightforward and do things that we expect them to do, we don't really see them as AI anymore. It's just, it's just software. But it is important to be part of this. And it's really easy as well to think that, sure, artificial intelligence is going to disrupt most industries, but probably not mine, because and this is a direct quote from my dad, we're always going to need lawyers. And I'm like, first of all, I hope not. Second of all, and then I got to show him this article, and I might show you in a second, and we're not always going to need lawyers. We will for a few more years, but the changes that are going to come are going to change radically how law is done and how lawyers operate. All right. So I'm going to go through a few kind of areas just to show you how I think about AI and how I kind of try to envision the future with the reality of today, potentials, and then this crazy future that we are going to live in, where everything is going to be a little Star Trek-y. And we're going to go through a few areas, and then what I'm going to do is I'm going to dig into my company and what we actually do, again, to give you a little bit more of that tangible, concrete, like, what is this thing really? How do we actually do it? And then at the end, and I'm hoping to time this right, we're going to go through and discuss a little bit more of some ethical issues and some really tricky questions. And we'll see how much of that we have time for as well. Let me just check my timer. Okay, perfect. So I'm going to take image recognition first. Recognizing that a cat is a cat and not a dog is something you could do at the age of about 3, right? As a kid, maybe 4. Depends on the kid. But kids very rapidly learn to say, oh, that's a meow, you know, dog, woof, whatever language the kid is speaking. And that is very easy for a kid. It's very intuitive. They see the difference between a cat and a dog fairly rapidly. However, for a machine, that's been really tricky. How do you tell a machine what a cat is like? Well, it has ears. So does dogs. It has 4 legs, so does dogs. It has fur. So, you know, there's no real way to classify what a cat is and what a dog is if you want to distinguish between all of the breeds and all of the sizes and all of the, you know, positions they can sit in and images, etc. So up until recently, it's been really tricky, and it's been one of the kind of hurdles in image recognition to recognize that a cat is, in fact, a cat. But in fact, as of last year, AI algorithms were better than humans to recognize that cats in a picture are in fact cats. The computer's error margin was about 3% errors. Human average is about 5% errors in defining that a cat is a cat. And that's where we're at right now with image recognition. We've seen a massive breakthrough the last couple of years in this field, and that includes facial recognition, both in still pictures and in video, to a certain degree, recognizing objects, recognizing tumors or the beginning of tumors in x-rays of lungs. And that is where we're at right now, where machines can do that better than humans. The next few years, we're going to move over, of course, moving away from just lungs, but to full body, and really have machines help us understand everything that is going on visually in our body. Biometric security is also going to come more and more into, and there's been a few talks about security here, and kind of retina scans and fingerprint scans and all of those things. Will be a variety of things where we can use image recognition. Surveillance, obviously, there's some ethical discussions there, like, you know, if our government, which they do, have access to this kind of technology, when can they survey us? When can they know? If they can recognize at, you know, 500 meters distance your face and know that it's you through a crowd and match that up with every single Facebook profile picture you've ever had, you know, organize a protest against Trump, and what's going to happen, right? So that's kind of the next few years, and we're talking, you know, 3, maybe 5 years before this is kind of everywhere. And then longer term, of course, having, you know, a combination of cameras, sensors everywhere, will move more and more into live, real-time, full understanding of what's going on the globe. Not just our faces, of course, but things like crops, things like disasters and emergencies. There's a variety of causes and problems that can be solved by having image recognition and image understanding from around the world at all times. Such image recognition. And of course, let me go back for a second. And of course, image recognition is converging. It's not working very well. Okay. Image recognition is converging with a variety of different fields. For example, enabling autonomous vehicles is one of those things where image recognition is vital for the vehicles to actually operate the way they do. Then we have natural language understanding or natural language processing. There we go. Damn it. There we go. And what we can do already now, which is the field I'm working in, is understanding what a document really is about, understand a text, what the document means. We have kind of the crude beginning of chatbots. Chatbots is also one of those big hypes that everyone is talking about, and let's face it, they're kind of useful, but they're not really that smart. But they are being enabled more and more, and will become smarter because they learn over time. And we also have static speech generation, or, you know, Siri talking back at us. And it's not perfect, it's far from it, but we're seeing breakthrough after breakthrough in that area. Which means over the next few years, we're also going to see more and more natural speech generation, having robots that really will sound more and more like human and not be in this, what's called the uncanny valley, where humanoid robots are kind of creepy, because they kind of sound human, but kind of not, which is called the uncanny valley. Same with the visual of robots. And we're going to see more and more that the flow of speech in robots and computer systems are going to become more and more very much like a human. And the same goes for natural language summarization, taking a long text and summarizing it in human language. And of course, longer term, we'll see these systems passing the Turing test, speech generation with kind of human emotions in it. DeepMind actually had a really interesting experiment on that, where they could add in ranges of emotions. The computational power needed to generate it is more than even two kids in a garage has these days, so it's still on the early stage, but we're going to see that more and more, adding emotions and feelings and relating to different people in different ways as an AI. And of course, learning new languages, etc. So a couple of the areas that was mentioned, I mentioned this one earlier, in legal work, for example. What we can already do today through AI and machine learning is navigate through millions and millions of documents, finding the right documents for you, and of course detect differences in documents. And this is something we can do on a massive scale that couldn't be done just a few years ago. The next few years, and this one, this is one I showed my dad that I mentioned earlier, where actually AIs are going into legal firms already, and the interesting part is that we're still going to need the kind of senior, well-experienced lawyers that can argue the case in court. We're not quite there yet with the AI systems. However, AIs that do all the grunt work is going to replace everyone junior, because the way you learn to be a lawyer today is doing a lot of the grunt work. So we only need the senior lawyers. Now, how are you going to learn to be a senior lawyer if you don't get to do the grunt work for a number of years? And I'll pass that challenge over to the universities, so you guys can figure that one out. And as over the next few years, we'll see all of this grunt work done by machines, and we're going to need new ways of learning to become a lawyer, for example. And longer terms, which is what I'm really excited about, is having more automated decision-making on basic disputes. And you can combine that, for example, with smart contracts through the blockchain, which I'd love to talk more about, but I'm not going to do that because we don't have time. When you have smart contracts to blockchain, you actually completely remove the need for lawyers, because you have a contract with a variety of factors playing in, and at the end where the contract needs to be executed for whatever reason, which is also embedded in the contract, it will be done so automatically and the dispute resolved, as per the initial agreement. And these can all be done automatically by a combination of blockchain and artificial intelligence. And at that point, we don't really need lawyers in those basic disputes. And of course, we're seeing this beginning of a new era of justice, which, in these post-truth days, might actually be a really good thing. Another one is manufacturing automation. Let me just check my time here. All right. I'll actually just skip by this one. Manufacturing automation is one of those areas where we'll see so much happening and more jobs changing and or disappearing thanks to AI, which also, again, what do we teach our engineering students in the future when manufacturing is fully automized? And of course, in education, and we did, talk a little bit about this yesterday during the debate. We were already seeing there's been an experiment on where one of the teacher assistants, and the university is escaping me right now, so if anyone knows it, please yell it out, but where the teaching assistant was actually an AI, and none of the students knew, and they were engaging with this teaching assistant for a number of kind of basic questions throughout the year. Whenever the question couldn't be answered by the AI, the actual human would take over. And it wasn't until the end of the semester that the students were alerted to the fact that they'd been talking to an AI for a number of months, just over email. It's a lot easier to get tricked by email than it is via voice, as the previous example that we discussed illustrates. And then, of course, there's recommender systems for MOOCs, similar to, for example, Netflix recommendation engine. They're not really that smart yet, but it's getting there, right? A friend of mine is developing this system for videos where you can, for example, search for videos. I don't know why you would do this in an educational context, but you can search for videos, but like, I want videos of men in red pants, or trousers if you're British. And, and you can find videos that contains that. So they have this video or image recognition software where you can very strictly define what you want to find in the video. Over the next, oh, there we go. I even had the reference, right? Jill Watson was the AI that tricked all these students. Over the next few years, what we're going to see more and more, as I alluded to yesterday, is more and more self-education, more AI-based assessments, assessing tools that will learn with the student over a number of years and actually understand what they know, and removing, more and more moving to removing the need for actually having an in-person exam or a specific home exam, because the AI system will actually know what you learn, and of course, adaptive curriculum, and which I'll get to in a second and talk a little bit more about, research assistants. Sorry, I'm a little bit far away from my my screen. Okay. We'll give you a little bit of a break anyway. Teaching assistant. Okay. The Global Learning X Prize is now in the rollout, and they have 200 teams that is working on it. And their goal is to build an AI-based platform, open source, where any kid anywhere in the world, in the span of 18 months, should be able to learn basic reading, writing, and math skills. And the goal is to have this adaptive system where any kid can go on it and learn what they need to know to function and to take their own learning further, which is a really exciting project. And again, it's a few years into the future, but this is coming. And finally, what I'm kind of excited about, if you remember the one laptop per child movement, if we're moving into kind of a one AI per child, and again, into the, a more distant future, but where you have an AI system that gets to know you from birth through testing, interaction, talking to you, the system will learn who you are, how you learn, how you best will adapt to curriculum, and keep track of everything that you do learn, so that kids who need really kind of kinetic forms of learning can do that, while kids who really function best sitting down with a book with no disturbances can do that, and not have kids forced into the system that we do today, where they're put into boxes and have to learn the same way as everyone else. And having that, personal tutor, an AI-based system that can do that for you over the course of your childhood years and as you grow up. I'm really excited for that one. And of course, again, this is 10, 15, 20 years into the future. It's not something that's going to happen right now, but that is the future that we're looking at. And of course, combining artificial intelligence with AR and VR experiences that we talked a little bit about yesterday, neuroscience, understanding more and more how we learn and what's going on in our brain, and of course sensors to track everything that is happening around the student. All right, so I want to get a little bit more concrete, and the clock is running really fast, guys. I'm going to try to, I'm going to move these things. So I wanted to show you there we go. So I wanted to show you the tool that we've built. I'm going to give you a very, very quick product demo. And then I'm going to take you through a little bit of the technology behind it, what we're actually doing today, just to give you a feel for what can be done today. And then I'm going to talk a little bit about the future and the exponential growth of the tool that we're building and where we're hoping to be. Very quickly, what we are aiming to do is building an AI researcher. So an AI system that you can give a problem statement, research question. She will go out, read all related material in the world from the 150 million plus research papers, plus internal documentation, plus patents. She will create a new hypothesis, test that hypothesis in a robotic lab or a simulation environment, then come back to the human and present what she found in a legible, understandable format for the human. And that's going to take us about a decade. We've been working on it for 2 years, so I guess it's 8 years left. And that's what we're working towards. And I have said that to people, and they laugh and think we're not serious, but that is what we're working on, and that is where we're going to get to, if we get proper funding and all of the commercial obstacles that stand in our way until we're there. But I wanted to show you what this tool can do today. And what we decided, oh, there we go. And what we decided to focus on was removing the need for keyword searches, removing the need for these endless result lists of results that you have to skim through with Google Scholar, etc., and removing the biased citation system. We could have a discussion on that if anyone disagrees with that later, but that's what we're doing. So I picked a research paper from one of the speakers yesterday because I heard the talk was really good, and unfortunately I didn't make it. She was talking about the future of technology and how AIs might replace her job. Someone told me that was a statement, so we're not replacing her jobs quite yet. But what we do, this is Iris. We use Iris to explore research. So what you do is you input the URL of a research paper into the tool. And I hope the Wi-Fi connection holds here. Yep. So that was the correct paper. And what we do is that we use the abstract to map out, this is what this paper is about. So these are the main topics. This is all computer-made. There's no human taxonomies. No humans have told us anything about this paper. We strictly work with the text of the paper. And what you can do is zoom into the topics you want to learn more about. And culture sheets, dermal sheets is about engineering cultured human skin. And at the bottom here, we're going to find research papers on that topic. Right now, this tool is free, available on our website. If you have PhD students that are doing their literature search, feel free to share it with them. And these are all open access papers that we're dealing with right now from a database of about 70 million. And you can open them up, read the abstract, use the new paper you found to make a new research map, etc. We also do have a version where and I'm not going to demo it for lack of time, but where you can actually input not just the URL of a research paper, but a written problem statement, 300 to 500 words, your own words put into the tool, and you'll get the similar research map. So as a PhD student, put in your thesis question, and we will map out the science. Now, this is a fully automated research landscape mapping. Obviously, we make some assumptions. So probably, maybe 50% of the papers will be more noise. The other half will be really, really relevant to what you do. And we are working with our next step. I'll get into that in a second. But let me get back to my presentation. Right, so this is Iris. And as I said, we work with removing the need for keywords, removing the needs for these endless result lists simply via the UX, and the bias citation system. The way we do it, and unfortunately I don't have the full time to go through everything, but this is the outline of the algorithm based on machine learning, deep learning, neural network, all of the fancy buzzwords that people are talking about, but it works, right? So what we do is that we start with extracting the terms that are actually in the document. And this is a statistical model, machine learning model, fairly straightforward. These are the most meaning-bearing words from the text. Great. Then the next thing, so here's one example. So from this paper, we extract these 5 words. These are the words that explain in very brief what this paper is about. The next thing we do is work with contextual synonyms. And here's where the learning comes into the picture as well. We've trained this model, Word2Vec, on about 18 million other research papers. And doing that, we are able to identify contextual synonyms from all of these other papers so that even if in the original paper or text you input, say car, we are able, or say vehicle in this case, we are able, or our system is able to automatically understand that you're also talking about car, automobile, potentially passenger, etc. So we expand it with contextual synonyms. Then we use a neural topic modeling where we look at, here's your document, here is 18 million other documents. Now we're going to cluster them into topics, and we're going to understand what each of these topics are about. So in that way, we find hypernyms. So let's say you have, dog and cat. The hypernym could be animal, it could be pet, it could be mammal, it could be food, depending on what country you're in. So we find these related words. And take that all together and form what we call a fingerprint of the document. So it is a list of words, it is weighted, we understand our system understands the true meaning of the document in a weighted form. We use that to go out and look at fingerprints of all of these other documents and match them up so that we know how related they are. Again, with distances, so the more related they are or the less related they are, we have all of that information. All of this is done in a vector space where we have about 100 different dimensions, so we can really slice and dice the content in a variety of different ways. And then we create these hierarchies that you saw with a few main topics and subtopics, and present that back to the user. So, and pardon me for going through this a little fast, but it's not magic. It's complex. It solves some really good, serious problems, but it's not black magic in the sense that sometimes AI is portrayed. It's fairly straightforward. What we're doing right now is that we're working with Chalmers to take this automated process, to break it down into smaller components and make it semi-automated. And without going too much into detail, what we're seeing is that we can take a systematic mapping study that takes 3 to 6 months to do manually. We can get that down with the same accuracy of 99.8%. Looks like we can get that down to about 1 month. And if you work, for example, in industry, or if you work in a project where you don't need that level of accuracy, we can get it down to about 2 days. That is the tentative results. And again, we still need researchers, for sure, but we can narrow down the manual labor that is required to do so, but so you can focus your time as a researcher on actually understanding and implementing these solutions. A little bit of the longer-term vision, because this is today, this is the next 6 months or so that we're building this semi-automated tool, which is very, very exciting, of course. Over the next few years, what we're going to do is we're going to start extracting the hypothesis of the text. So not just matching it, but actually extracting what is the hypothesis, the problem, the solution, evaluation, result. And then we can do similarity graphs, or big, as I talked about these vector spaces, where you can compare hypotheses of different documents to start seeing patterns of knowledge and patterns of information over time and in different fields. And in that way, we're going from contextual exploration, which we do today, where we more than twice outperform Google Scholar, for example, in the tests we've done, to a more proactive AI assistant that will help you in your research over the next 3 to 5 years, and then eventually by 2025 or so, end up with this AI scientist that can actually go out and do research for us at a speed that human beings just can't compete with. So again, it's a little bit of a crazy vision, but it's a very concrete starting point that we can solve today. Very briefly, if you want to get involved with what we do, I'll do a little bit of a plug for that. The free tool that is available on our site is free to be shared with anyone, and we love to for people to use it. We also look for research partners and pilots for the semi-automated mapping study tool that we're going to do in November, December. I also have stickers. If anyone likes the sticker, you're welcome to come over to me afterwards and get a sticker. So that was very quickly about what we do, and I hope that gives a little bit of an understanding for, I guess, how to think about AI, because really, it's not that tricky. It's just building software. It's just a different way to go about it. So when you think about AI and how to apply it in your projects, whatever they are, it's pretty straightforward. You start with what is your problem? What is the problem you're trying to solve? And I talked to someone yesterday about those tedious questions where you get the same question over and over again from students. Like those things, could we like remove the need for manual labor in that? Sure, that can be done through AI, and it's already being done through, I know the Watson has some of that functionality and a few other projects as well. So it's fairly straightforward to get started with it. I know I'm running a little bit short on time. I can keep going, awesome. So I want to talk just a couple of more things around the ethics of it, not tied to our project necessarily, but kind of to AI at large, if we take that bigger step back. When I tell people that I'm building AI for a living, or run a company that does it, one of the questions is always, of course, are you building Skynet? And as I said, that is the artificial superintelligence, and that is a long time into the future. So More important to discuss today are perhaps this one. What about our jobs? Are our jobs disappearing? And fact is that, surveys show that about 60% of students are chasing jobs that may be rendered obsolete by technology. What are we teaching our kids? What should we be teaching them? Personally, I think that, and this was mentioned yesterday during the debate as well, critical thinking, problem-solving skills, creativity, learning and adaptive learning, learning new things are things that we really need to teach our kids and our students that we're not really succeeding in teaching today, more so than the specific skills that will be changing more and more rapidly. There's a lot of things that could be said about the future of jobs. I'm actually not going to go there right now because there's one other topic that I really want to talk more about, which I think is essential, which ties back to what I said in the beginning. Like, I'm not a coder. Sure, I happen to run an AI startup, but I don't really have a say in the AI world. I don't have that authority, right? That was my feeling. But AI, I'm sorry to all the white males in the room, but AI has a white guy problem, right? We don't have enough diversity in AI, and not just gender, but across the board, whether it's sexuality or skin color or where you stem from or where you grew up, socioeconomic status. We have a white guy problem. And one of the examples of this is from a police district in Florida, where they had an algorithm, machine learning algorithm, that was given a lot of data from the district to assess whether or not someone arrested would be likely to do a repeat offense. And these are two people that were arrested more or less at the same time, more or less of the same offense. It was stealing goods of about $80. So it wasn't a major offense. It's one of those things that kind of quickly come and go through the police station. And Brisha was assessed to be a 8 out of 10 likelihood for doing a repeat offense. She was a juvenile delinquent. She'd done a few different things before, but really not that much. While Vernon, he had repeated multiple felony charges already. And when ProPublica went through this case and 1,000 other cases, balancing out a variety of factors, they had only one conclusion to make. This algorithm was racist. There's no other way to explain it. This is a racist algorithm built, probably, I hope, by well-meaning people, but that weren't aware of their own racial biases. So when they selected data, when they trained the system, they didn't have their own biases in check, and they ended up with a racial profiling and biased algorithm. And we're seeing that not just and that's of course a very severe case, but also things like this, beauty contests, right? The whiter your skin was, the higher score you would get because of the images that were selected by the jury and by the peers. They selected generally whiter skin colors to be more beautiful. That was a training data set, and that's what you end up in. We need diversity in all of these fields, and we need everyone to have a voice so that we don't end up with examples like this. There's also, of course, the fact that a lot of our AI systems, especially the assistants of today, end up with female pronouns and female names, because as females, we're generally more servile and assisting and helpful and all of that bullshit. Pardon my French. Now the fact is, we have an AI system that we call she, and when I started thinking about this, I'm like, oh shit, what do we do? And I gave it a little bit of thought, but hey, our Iris is going to grow up to be a fierce researcher someday. I mean, I'm super proud that she's a she. That's our take on it. And so there is challenges ahead, definitely. And we need to talk about it, right? And we need to be aware of our biases in this process. But there's also such an incredible amount of things and good things that can come out of it. And I remember reading this case. There's this chatbot that could overturn parking tickets. And I remember reading about that project. It was, it was a 17-year-old kid, I think, 18-year-old, 19-year-old, that built this robot lawyer. And I remember reading about it. I'm like, really? Overturning parking tickets? Like, can we not? Sure, I guess that's great, but like, if you parked wrong, why don't you just pay the fine and get over with? I am very much of the school that we should solve real problems in the world. But then I read this article, and that same system is now being used to help refugees claim asylum in a similar process, helping you through step by step, navigating this maze of public websites that are hard to understand. The same system that helped you, reclaim a parking ticket helps refugees seek asylum. So there are so many amazing causes, really difficult problems that are being and will be solved through AI. And that is one of the reasons why I'm doing what I'm doing, obviously, and why I'm so excited for AI, even though there are going to be challenges, there are things we need to discuss, there are hard choices to be made, and biases that we need to face ourselves, and of course, some distant future that might be dystopic, utopic. We can have that discussion over some drinks a late night. But the future is really amazing, and it holds a lot of promise. And we're just at the starting point, but I would like to challenge each of you, especially those who work with IT and software systems for your universities. Start embracing this already now. Start educating yourselves. Kind of jump into it with a little bit head first. It really isn't. I was going to say rocket science, but I guess we've got some scientists in the room as well. It really isn't all that. It is, at the end of the day, just software, but it holds an incredible potential for the future of learning and really everything else as well. So for that, I'm sorry for going over. Thank you very much for your attention.